Welcome to your introduction to macromolecules. Now that word might not be familiar to you, macromolecules, but I can assure you that you have heard of macromolecules before. Macro means large. So macromolecules are large molecules. Macromolecules are made up of smaller building blocks called monomers. What do you think the word mono means? Macromolecules are organic compounds. Inorganic means it's not living, it doesn't contain carbon, and these are things like oxygen or metals, rocks, and water. Whereas organic compounds contain carbon. Organic has carbon. Organic compounds are living or were once living. An example of this is glucose. So if macromolecules contain carbon, that means that macromolecules are organic. Look at these 5 compounds. Which of these compounds is organic? H2O. I don't hear a K in H2O. There is no C for carbon. So H2O, also called water, is not organic. SO2. There is no C in SO2. So SO2 is not organic. The other 3 compounds have a C. However, you need to make sure that the C is for carbon. These other 3 compounds do have a C for carbon. So the other 3 compounds are organic. So we asked you, what does mono mean? Mono means one. Monomers are one unit that can build up into polymers. Polymers means more than one. Think of these like beads on a necklace. A monomer is one bead. In and of itself, it does not make a necklace. However, a string of beads, a bunch of monomers, is a polymer, a complete set for a necklace. There are 4 macromolecules that we're going to learn about. And these are the words you probably have heard before. The first macromolecule is a carbohydrate, or you might have heard it called carbs. Carbs are things like sugar, bread, pasta. These are foods that have a lot of carbs. Carbohydrate is the polymer, the macromolecule, which means it's built by a bunch of smaller pieces. The monomer is a monosaccharide. This translates to one sugar. That's because sugars are carbohydrates. Lipids. Lipids are fats, things like oil and butter and even animal fat. Lipids are the macromolecule. They are built by smaller pieces called fatty acids. How I like to remember this is that if you put food to your lip, you get fat. Lipids are fatty acids. The other food you might have heard of is proteins. Proteins, if you're eating them, it might be something like fish or meat. If you're a vegetarian, you might get proteins from things like seeds or nuts. Proteins are built by amino acids. If you're someone who's really into going to the gym and you take protein powder, you might have heard protein powders bragging about contains 12 different amino acids. What this really means is that there's a lot of protein in that protein powder because amino acids are protein. Nucleic acids, Na, this is your DNA or RNA. These are nucleic acids. Anything that's living has nucleic acids in it. Nucleic acids are built by the monomer nucleotide. So they sound similar, so it's not hard to find that these two match together. Nucleotides build nucleic acids. So let's talk about the function of each of these macromolecules. I always like to relate it to food because when you think about these macromolecules in food, it makes sense what they do. For example, carbohydrates, carbs, sugar. What do you get when you eat a lot of sugar? Well, you get quick energy. Think about a kid on Halloween who just had his 12th Reese's cup. He is bouncing off the walls because he just had a lot of sugar, which gives you quick energy. Carbohydrates are made of carbon, hydrogen, and oxygen, CHO. I like to think of carbohydrates as choo-choo because they get you going. Lipids for long-term energy. If you're trying to make sure that you don't get hungry, you want to eat things with lipids in them. Now, there are good lipids and there are bad lipids. The good lipids are unsaturated fats. These are the kinds of fats you get from eating avocados, nuts, seeds, olive oil. There are saturated fats, which are the bad lipids. These are the kinds of fats you might get from eating cake or ice cream or butter. Lipids give you long-term energy. That's because lipids can be stored in the body and used at a later time. So if I eat something with fat, my body might hold on to it until I need energy later. Lipids also, when they're stored in the body, help keep organisms warm. That's why seals have a lot of fat on them in the winter to help protect them from the cold. Lipids are also made of carbon, hydrogen, and oxygen. Choo-choo, carbs and lipids, these two give you energy. Nucleic acids. These don't really do anything fun for you if you ingest them. However, they're a really big part of an organism because nucleic acid is your hereditary information. It's your DNA. Or for other organisms, it's your RNA. These are responsible for storing important information about you. Nucleic acids are made of carbon, hydrogen, oxygen, nitrogen, and phosphorus. Because they're so important, they're made of a lot more elements. CHONP, chomp. Nucleic acids are found in all foods. Chomp, chomp. Proteins. If you're an athlete, you've definitely been told to eat more protein. That's because proteins help build muscle. They do not give you energy. Proteins are there to help build muscle, grow hair and nails, and also help with your body's speeding up reactions, like enzymes. Proteins are made of amino acids. The four compounds that make up proteins are carbon, hydrogen, oxygen, and nitrogen, CHON. Again, proteins do not give you energy. What they do is they give you muscles. So, which macromolecule is going to be best for long-term energy or energy for later? You'll notice I keep emphasizing the L sound. That's because it's lipids. Monosaccharides are the building blocks to which macromolecule? Remember, mono means one and saccharide is sugar. Which macromolecule is sugar? That's going to be your carbs or carbohydrates. DNA and RNA are an example of what macromolecule? Hint, they both have Na. That stands for nucleic acid. Enzymes are a very specific type of this macromolecule. Which one is it? This one's a bit of a tricky question because this macromolecule has a lot of different functions. The answer is protein. Proteins build muscle, and they also help speed up reactions in these small molecules called enzymes.